Section 3.3 of Timberlake Basic Chemistry on temperature. Temperature has a lot to do with energy. So the amount of energy that a compound or a molecule or an element would have can have something to do with whether it's a solid, liquid, or gas. It also has to do with the amount of heat that object is containing. So whether you put energy into it, you can often change the temperature just by adding. So you put something on the Bunsen burner, you put something on the stove, and by adding energy into that material, you can change its temperature. You often do. In fact, we think of temperature and heat as really the same thing. And heat, we're going to see, has a kind of a wider definition in chemistry of energy that you're adding to a system. And we'll talk about that at a different time. So temperature is how hot something is compared to something else. And heat will naturally flow from a hot object into a cold object. It doesn't require energy to do that. It's just something that diffuses. Heat will always go from something hot to something cold. So if you have the handle of the frying pan is very hot and your hand is very cold, the heat will go from the pan into your hand and maybe burn your hand. If your hand is hot relative to the snowball that you're holding in it, you can melt that snow simply with the body temperature that you have by the heat coming out of your hand and into that snow. So it's measured using a thermometer. And you'll see that the thermometer has different scales on it depending upon who is using it and for what purpose. So there are 3 temperature scales. Most of the world uses Celsius, which is a metric scale. And the United States and only a couple other countries will use Fahrenheit scale. And so for that reason, you have to be able to convert between Fahrenheit and Celsius. Kelvin has the same width of a degree as a Celsius degree, but Kelvin continues to go below Celsius 0 because we'll see that Celsius is based upon the properties of water, and Kelvin is based upon the energy added to a system, giving it motion. So for instance, anything, whether it's a solid, liquid, or gas, is going to have a certain amount of energy until it gets to 0 Kelvin, when it has considered to be no energy, no molecular motion at all. So a Fahrenheit formula has to do not exactly with water. So water freezes at 32 Fahrenheit, and water boils at 212 degrees Fahrenheit. So a Celsius reading is going to be a little bit different. Celsius is going to be based upon water. So if you were to have freezing water, ice, that is considered 0 degrees Celsius, and water boils at 100 degrees Celsius. So when it was contrived, the system simply took the difference between freezing of water and boiling of water and divided that by 100 parts and made each of those parts 1 degree in Celsius. And centigrade was the old word for Celsius, and centigrade just means based upon 100 parts. So 100 divisions of water from frozen water to gaseous water. So if you're going to change from Fahrenheit to Celsius, you are going to have to convert between the large width of a degree from 32 to 212. That's freezing water to boiling water. That's a large number division compared to 100 degrees in Celsius. So 100 has to go into 180. So you can see that they're different sizes. So you have to allow for the different sizes, and then you have to compensate for where freezing is. So in Celsius it's at 0, but in Fahrenheit it's at 32. So you have 2 things to compensate for: how big that degree is between Fahrenheit and Celsius, and where does freezing start. So we're going to see that for instance, Fahrenheit, the sun is 10,000 degrees Fahrenheit, but Celsius is only 5,500. So that's not the biggest of differences. As you get closer down, you're going to see that they appear much more different. So 32 Fahrenheit to 0 degrees freezing, or 100 degrees to 212. So as you get into a smaller sample, it does change a lot. So when you are changing from Celsius into Fahrenheit, you are going to want to go into a bigger degree, and when you do that, you're going to need to multiply by 9/5. So you take whatever your Celsius degrees times 9, divide it by 5, then you're going to have to add the 32 degrees. So from Celsius to Fahrenheit, take your degrees Celsius, multiply by 9, divide it by 5, and then add 32. If you have Fahrenheit, you need to get rid of your 32 first, then multiply by 5 and divide by 9. So it's a difference of 9/5 and 5/9, and either adding 32 or subtracting 32. And what I want you to keep in mind is that if you're going from Celsius to Fahrenheit, you're making it bigger, so you want to multiply by a bigger fraction, so that's 9/5. And if you go from Fahrenheit to Celsius, you want to go to a smaller degree and the width of a degree, and so you're going to multiply by 5/9, which makes it smaller. And when you're making it smaller, you're going to subtract 32 first, and when you're making it bigger, you're going to add 32 last. So confusing to a lot of people, so I hope this helps you.